Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In this video, we're going to talk about linear sliding wear. It's a part of chapter from Chile Mechanical Engineering Design book. Okay, so what is linear measure of wear? So what is a wear? The first thing, what is a wear? Wear and tear is will happen for any parts or any things. Okay, you have learned in your machining class, in other subject, when you do machining, when you use a milling machine, turning machine, there will be tool wear, material wear, uh, okay, material removal rate, and anything and everything. This is the same concept. Okay, where will happen, okay, on the journal. Okay, so we this video and this subject will talk about where itself. Okay, consider a sliding block in picture in figure 1238 moving along a plate with contact pressure P prime acting about over area A in the presence of coefficient of sliding friction Fs. The linear wear measure of wear W is expressed in inch or millimeters. Now here, okay, now I want to highlight this symbol W. This book and many other books, okay, this symbol is a symbol for radial velocity. Okay, many in the literature in this book and also in other books use the symbol W as radial velocity. Okay, that is why I always suggest you, when you read the chapter, you always pronounce it as its name, because this chapter, the symbol used is different meaning. Other chapter is different meaning. Other subject is different meaning. So always mention its full name until you are familiarized with it. Okay. Uh, so W, the work done by force FSPA during displacement S is FSPAS or FSPAVT. So here is another example. S in this chapter you know as Sommerfeld number, but in this subtopic on linear wear, S is linear is displacement. S is displacement. Okay, so don't be confused. You may uh, you may know displacement as the symbol X, also displacement. Okay, from the theory from the deflection of beam chapter. Okay, deflection is X. This displacement is also X. Okay, so in this subtopic, displacement is represented by the word S. Also in this subtopic, Sommerfeld number is also represented by the word S. So don't be confused. Always mention it as full name. Okay. So Fs is sliding, PAS, FS, PAVT, where V is the sliding velocity and T is time. The material volume removed during wear is WA and is proportional to the work done. WA is material removed proportional to Fs, VA, or WA equals to K. K is stand for proportionality factor, which includes sliding friction. Okay, is the main from laboratory testing. The linear wear in express is W equals to K V VT. Okay, this W is linear wear, K is proportionally factor, P is the pressure, V is the sliding velocity, T is the time. Meaning that it proportional, like you boil the water. I give a simple analogy that you see every day. You boil the water, the heat rises, the until it reach in proportionally until it reaches the boiling point of 100 degrees Celsius. This is linearly linear. It is linearly, okay, proportional. The heat rises, the temperature rises, and the water will boil. This is a simple analogy to make you understand. Okay. sliding block subject to where. Okay, this is meaning that if you imagine from the journal, let's say this is a journal. Okay, this is the bushing. Okay, you take one point, one particle, one element inside this, and you imagine this is element as this figure 1238. Okay, this is how you understand this figure. Okay, sliding block subjected to where. Okay, PFAS, shear stress area PA. Okay, you can imagine how relate this with this journal. S here is the sliding displacement, not Sommerfeld number. Okay, but it is a sliding displacement for the wear. Okay, units in US customary units. P is expressed as PSI, V is FPM, feet per minute, and T in hours. Makes units of K inches, inches cube. Okay, mm. SI unit commonly used for K are cm cube per minute, where 1 is a kgf, 9.806 Newton. Okay, table 1238 and 1239 give some wear factors and coefficient of friction from one manufacturer. Okay, here is the table 12.8 wear factors in US customary units. Okay, US customary, this is a bushing material, this is the wear factor from US customary units. For other countries that don't use US, maybe you have some conversion uh, for unique for them. Okay, this is the oil list, this is oils, polymer and everything. Okay, this is the coefficient of friction. Okay, for the type plastic composite mat. Okay, this is bearing, this is a FS, the sliding friction, sliding, yes. Okay, you can read it, dry mat, SD star mat, everything. And this is the modifying factor. It is useful to include a modifying factor F1 depending on motion type, load and speed, and environment factor F2 to account for temperature and cleanliness condition. See table 1210 and 1211. These factors account for departures from laboratory condition under which K was measured. Okay. Question 1226 can now be written as this. Okay. W is the wear. F1, F2, K, P, V, T. Okay. This is the modifying factor. Where interproportional to KB, material property, operating condition F1 and F2, and time T. So this is the motion related factor for rotary, for oscillatory, and for reciprocating. Like that, reciprocating like that. Okay, oscillatory like this. No, oscillatory like this. Okay, the sinus graph, the oscillatory graph. Reciprocating is like this. Rotary like this. Okay. Okay, this is characteristic P, so 107. Okay, you can read this. This is the velocity. This is the F1 factor. Meaning that if you are dealing with condition of rotary condition, then rotary meaning that it's moving like this. Okay, you use this factor. Oscillatory, some up and down, up and down, up and down. Okay, oscillatory, and reciprocating it will jump up and jump down rapidly. Okay, so this is reciprocating. Okay, so table 1211 is the environmental factor. You remember the equation have F1 and F2. Okay, for ambient temperature is 140 or lower Fahrenheit. For you have to convert it from countries that don't use countries that use Celsius. Convert it. Okay, there is conversion in internet. You can see the conversion. Just type in Google. Everything is you can get all the value. Okay, this is the foreign matter, have foreign matter or no foreign matter, meaning that there is, if your bearing have no dust, no particle, there is no foreign matter. You have dust, okay, you have particles, okay, meaning that your bearing operated in harsh condition, you must consider a foreign matter because dust will come into your journal. Okay, so this is F2 and everything. So that's all for the video. We will see you in the next video on bushing wear. Thank you very much.